which one you isolate? Technically, no, but you get to choose any one you want. So which one should you try to go for, do you think?
No. X on the bottom.
Yeah, x on the bottom is kind of nice, because if we isolate x on the bottom, we end up with x equals 1 minus 4y plus 3z. So that's the same as what we had on 4.1. The same substitution method that many of you have used many times. What do you do after you've isolated? What do you do next, Meg? Okay.
Solve for the other two.
No, don't do. What do you mean solve for the other two equations? No, we're using substitution this time. Okay? You don't have to isolate z. You can isolate anything you want. You can isolate anything you want. What should we do next?
Substitute x into the top.
Correct. So let's substitute it into the top. And if we substitute it into the top, what do we end up with? Negative 1 minus 4y plus 3z. Plus what, Gabby?
Plus 2y plus 6z.
6z equals 2. And then we also have to substitute it where? Yeah, the second one. What does that one become? 3 times 1 minus 4y plus 3z. But this one's going to be plus what? 2y plus equals 6. How many equations do we now have right here? How many variables are present? 2. So theoretically, are we back to 4.1?
Yes.
Yeah, theoretically we are. What do we need to do before we solve those, though? What should we do? Distribute and simplify. We want to distribute and simplify. So let's distribute and simplify the top line first. We end up with what? Negative 1 plus 4y minus 3z plus 2y plus 6z is equal to 2. Can we simplify that further? Can anybody help me through this? Hannah.
Negative 1.
Negative 1, yep.
6y.
So you got 4y and 2y, so that's 6y, yep.
And then, wait, is that
It's a minus. Oh, and I just did too much. Sorry. Yeah, I know. I'm getting it back. It's plus 4y. It's minus 3z. It's minus 3z.
And plus 6.
Yes, it's minus 3z and plus 6z. Plus 3z equals 2. Now, is there something else we could do? Yeah. What form are we now in, Hannah? We're now in standard form. Do we like standard form? We do like standard form. We do like standard form. So we've done that to the first red equation, but now we need to do the same thing to the blue equation. So what's that first word? What do we like to do first? Distribute. So no, what do we get when we distribute on that one?
It's 3 minus 12y.
Yep.
Plus 9z plus 2y plus 6z equals 6.
Plus 6z equals 6. Can you combine some terms for me?
Yeah. So now we're going to have 3 minus
Yep.
3y.
3 minus.
Or no, I thought
3 minus how many y's?
Sorry.
3 minus
3
what?
minus 12.
3 minus how many y's?
10y.
10y.
Plus 9z.
How many z's?
15z.
Plus 15z equals 6. And what can we do at that point?
Subtract 3 from both sides.
Yeah, so you get negative 10y, not 110. That would change it radically. Negative 10y plus 15z is equal to what?
6.
Nope.
Oh.
Try again.
Oh.
3. So we have how many equations now? We have 2 equations. Now, why did we like to put y first and then z? Yeah, that actually is true. It's really, really nice if you put it in alphabetical order so that you can keep track of the variables. So you keep track of the variables. We now have 2 equations. 6y plus 3z equals 3, and negative 10y plus 15z is equal to 3. Before we actually write that down, is there something we could do to simplify this one right here? Not really. It's fine. We can start it this way. What are the 3 methods we have for solving 2 equations and 2 variables? What's one of them?
Substitution.
What's another one, Verdi?
Elimination.
And what's the third one? What one do you really not want to have to do on this one? Yeah, I really don't want to have to graph this one. Why not? Yeah, so when we graph this, we're looking for the intersection of 2 lines. What's that liable to look like? It's going to be really hard to accurately gauge where the intersection point is. So what method go ahead.
Would you use like elimination?
Absolutely. So we absolutely could use elimination. That's totally fine. If we wanted to use elimination on this one, we have to multiply the top and bottom by something so that we can cancel one of the terms. Anybody want? There's multiple choices you can make. Anybody want to pick what we're going to multiply by? Hold on a second. Noah, go ahead.
Multiply the top by -5.
-5? Sure. And what's the bottom one by? Oh, do we need to? Oh, I like that. Good. Yeah, you don't need to. I like that. That's nice. So what does that become? Negative 30y minus
15z
equals
negative 15.
and negative 10y plus z equals. It's the same equation, right?
Yeah.
Why did we do that? What's the number that's really nice? Sarah, please stop. Yes? The 15s. Why are those 15s really nice? You get to cross them out when you do what? When you add them together, exactly. So when I add these together, what do I end up with? Equals negative 12. And now can we solve for y?
Wait, what happens to the z's they cross out? That's where I messed up.
You just told me what happened. Negative
Did
15.
you also cross out the z's?
Yes, because negative 15 apples plus 15 apples is how many apples? No, I'm serious. It's 0 apples.
Yeah.
0 times anything is 0. So you have 0 z's, so the z's go away. That's the whole point of why we were doing this. So what does y equal at this point? What do you divide both sides by? So you have negative 12 over negative 40. Does that simplify? 12 over 40, does that simplify? 6 over 20, 3 over 10. We have one of the three numbers. What do you now do? We're not going to do it right now, but what do you do with the 3 over 10? So we have this one number. Where do we take this number?
You plug it in.
Where?
What?
Does it matter which one?
Oh, it's those.
Does it matter which one?
No.
No. We plug it in for here, and then we can solve for z.
And then you have
Z,
to solve
A, and then we have y and z, so then what can we do?
solve the entire equation.
You can go back up, and which one do you pick? How about that right there? If we have z and we have y, what can we find? X. So you do all this work so you can get 1, which gives you the second one because you're in a 2 by 2, but the first thing you did was solve for x right here. If you have z, if you have y, it gives you z, and if you have y and z, it gives you x. What is the dangerous thing about all of this math that you see right here? If you had to explain really simply what makes this challenging,
If you mess up,
there's a lot, and what
if you mess up early, that will destroy.
yeah,
the
if you mess up at the beginning, what happens?
Domino effect.
It's a domino effect. It goes really, really poorly. So on any sort of assessment that I give you, am I going to give you 6 of these? No. No. At most, how many am I going to give you?
2 and 3.
Maybe 2. Maybe. Usually what I do is I give you one that involves some work like this and one that's all by itself, or just one that's all by itself. Because theoretically, if you made one simple mistake, right? If you made one simple mistake and made that like plus 3z instead of minus 3z, what happens to your final answer? It's just totally bad. Oh, excuse me, that's a judgment word. It's just not the right one. It could mean like the overall, that's a fraction, and maybe you're not that happy to see that fraction, but could the fraction be a lot worse? Yeah, it could be 141 over 93. And then you have to plug that back in. And generally speaking, are you going to have a calculator for these? No. Generally speaking, no, you're not. No, you're not. Okay. Well, when you look at that, yeah, you might not like it too much. A, there's lots of variables, but also you don't like seeing a lot of the what?
Fraction.
You don't like seeing those fractions. So what have I taught you? You can do if you want to. Yeah.
Multiply each equation by a certain number, like get whole numbers.
Perfect. Perfectly said. Does it have to be the same number for each one? No, but you can get rid of them to help you out. The reason that's helpful is either the fractions are going to follow you through the entire process, or you can just deal with them at the end. So for example, Gabby, what could we multiply the top one by?
6.
Sure. Let's multiply by 6, and what do we end up with? 2x plus
Y
minus
4z
z equals?
negative.
Correct. And then what could we do with this one right here? Multiply by 12. Get negative 9x, I think, right?
Yeah.
Minus
4y
4y
minus 3z
equals
36.
36. And then, what can we multiply this one by?
4.
Yeah, 4. So it's going to be 2x plus,
6y.
is it, no, we're multiplying by, 6. You're absolutely right. Yeah. 6y, yep.
And then plus 3z.
Plus 3z equals
80.
84. Now, does everybody understand what we did right there?
Yeah.
Ah. Did we make it at least look a little better? I mean, the colors are nice, but does it numerically feel a little better?
Yeah.
It does. Now, at this point, are we back to the same type of process? Are we back to the same type of process that we've done before?
Yeah.
We're back to the same type of process. In this case, we want to use substitution. We have to find or choose one variable from one to isolate. Which one do you vote for, Noah?
The y in the top.
Yeah, why do you vote for the y in the top?
Because it doesn't have the, I can't remember the
Coefficient.
Coefficient.
Other than 1, yeah. That would be a great target. So you isolate y, and then what do you do with it? You then substitute, and that whole process we did before, it's the same type of math. You have to be very careful.
Yeah.
Yeah, you absolutely have to be very careful. Find a part of the board, everybody. Isolate y, and then substitute it into these two. Do that right now. Find a part of the two sideboards right there. The two sideboards.
Hate doing it on the board.